The spoon you stirred your coffee with this morning, the coins jingling in your pocket, the tiny hidden contacts inside the phone in your hand right now. What could these completely different objects possibly have in common? The answer is a single metal, silver. It's woven so quietly into daily life that most of us never stop to think about it. And yet, that bright, mirror-like shine you recognize instantly? It doesn't come out of the ground looking like that, not even close. Because silver in its natural state is anything but glamorous. It begins its life as dull, heavy, unremarkable rock, buried in darkness far beneath our feet, looking more like a lump of dirty stone than a treasure. Getting from that gritty rock to the gleaming metal we prize takes an extraordinary journey. A journey of crushing, burning, dissolving, and rebuilding, atom by atom. So how exactly does plain gray ore transform into one of the most treasured materials in human history? Let's uncover that remarkable story. Silver is a naturally occurring element. On the periodic table, it wears the symbol Ag, borrowed from its Latin name, argentum. It's been part of Earth's crust since long before humans existed, but here's the first surprise. Silver rarely shows up in pure form. You almost never dig into the ground and pull out a shining nugget. Instead, silver hides. It tucks itself inside other minerals, sharing space with metals like lead, copper, gold, and zinc. One of its most common hiding places is a mineral called galena. Galena is primarily lead sulfide, but locked deep inside its crystal structure, it frequently carries silver along for the ride. And this leads us to something genuinely strange about silver mining. Much of the silver we use every single day isn't even mined on purpose. It's pulled out as a byproduct, a bonus, while miners are actually chasing lead, copper, or zinc. In a way, some of the world's silver is found almost by accident. To reach it, miners choose their approach based on where the deposit sits. If the silver-bearing ore lies close to the surface, they use open-pit mining. Enormous earth-moving machines strip away what's called the overburden, the soil and rock blanketing the deposit, and then haul out thousands of tons of ore. But when the silver hides deeper down, that won't work. So miners carve tunnels and sink vertical shafts descending into the earth to reach the silver-rich rock directly. Either way, when that ore finally comes up into daylight, it's a letdown to look at. There's no sparkle, no shine. It's just a heavy, grayish jumble of stone. And the silver inside it is often present in astonishingly tiny amounts, sometimes just a few ounces hidden within an entire ton of rock. To free it, we're going to need some serious science. The transformation begins with brute force. First, the ore has to be broken down, and I mean literally shattered. It's fed into massive machines called jaw crushers and cone crushers, which bite down on boulders and reduce them to fist-sized chunks. But that's only the beginning. Those chunks then travel into ball mills, giant rotating drums filled with heavy steel balls. As the drum turns, the balls tumble and slam into the rock over and over, pulverizing it into a fine powder with the consistency of flour. Now you might wonder why we go to all this trouble just to make dust. It isn't for convenience, it's about surface area. Think of it this way. A single sugar cube dropped into your tea dissolves slowly. But grind that same cube into powder, and it dissolves almost instantly because you've exposed so much more of it. The same principle applies here. The finer we grind the ore, the more silver we expose, and the more effectively we can separate it from the worthless rock surrounding it. After grinding, we mix this powder with water to create something called slurry, a thick, muddy blend of ground ore and liquid. And it's out of this humble gray sludge that silver will finally start to reveal itself. This is where the process starts to feel almost magical. It's called froth flotation, and it's especially useful when silver is mingled with metals like lead and copper. The slurry is poured into large tanks and mixed with carefully chosen chemicals. Then air is blown up through the mixture, filling it with countless tiny bubbles. Now here's the clever part. Those chemicals coat the silver-bearing particles and make them hydrophobic. That's a fancy way of saying they suddenly hate water and refuse to stay in it. So instead, these particles cling desperately to the rising air bubbles. As the bubbles float upward, they carry the valuable silver-rich minerals with them, gathering at the surface as a thick, foamy froth. It's a bit like watching cream rise to the top of milk. That mineral-loaded froth is then skimmed off the surface and dried, leaving behind what we call concentrate. This concentrate is a far richer, more silver-packed version of the original ore. But make no mistake, it still isn't pure silver. It's a stubborn mixture of silver, other metals, and lingering impurities. So now, the real purification begins. Enter fire. This next stage is called smelting, and it's exactly what it sounds like. The concentrate is loaded into a furnace and blasted with heat so intense it can climb well past 1,000 degrees Celsius. For perspective, pure silver melts at around 960 degrees, so these furnaces reach temperatures that turn solid rock into flowing liquid. And as everything melts, physics takes over. The materials separate by density. Silver, being heavier than many of the impurities around it, sinks toward the bottom. Meanwhile, the lighter waste material, known as slag, floats to the top like scum on a pot of soup, and it's simply skimmed away. Now, if lead was present in the original ore, and remember it very often is that lead becomes surprisingly useful, it acts almost like a magnet for silver in an ancient technique called cupellation. This method is genuinely old, stretching back thousands of years to some of the earliest metalworkers in human history. Here's how it works. As the metals melt together, the lead absorbs and collects the silver. Then the molten mixture is placed into a special porous dish called a cupel. When it's reheated with a blast of air, something beautiful happens. The lead reacts with the oxygen and turns into a compound that soaks straight into the walls of the cupel, disappearing from the melt entirely. And what gets left behind, sitting alone in the dish? A gleaming bead of metallic silver. It's an astonishing thing to witness. This act of chemical separation that our ancestors figured out with nothing but fire, ingenuity, and patience. At this point, the silver is recognizable at last, shiny, soft, and unmistakable, but it's still not quite pure enough for the most demanding uses. For the highest levels of purity, the kind needed for electronics, fine jewelry, and investment-grade bullion, silver goes through one final, elegant step: electrolytic refining. If smelting is fire, this is electricity, and you can think of it as polishing silver not on the surface, but all the way down at the molecular level. Here's the setup. A slab of the impure silver is used as the anode, the positive side. A thin sheet of already pure silver is used as the cathode, the negative side. Both are lowered into a bath of silver nitrate solution, and then an electric current is switched on. Slowly, patiently, the current dissolves silver off the impure anode into the liquid, and then coaxes it to travel across and rebuild itself onto the pure cathode, one microscopic layer at a time. The impurities can't make the journey. Metals like gold and platinum simply give up and sink to the bottom as a dark sludge with a wonderful name, anode slime, and that slime is far from garbage. It's collected and processed separately, often yielding valuable amounts of gold and other precious metals as a reward. When it's all finished, what remains is silver that's 99.9% pure. In the trade, it's poetically called 3/9 fine. This is the exact grade used in fine silverware, in gleaming investment coins, and in the sensitive components of high-end electronics. From here, the pure silver is usually poured and cast into large bars, called ingots, ready for storage or sale. And the beauty of these ingots is their potential. Any one of them can later be melted down again and reshaped into virtually anything imaginable. Thread-thin wires for circuit boards, flat sheets for solar panels, delicate, intricate forms for a piece of jewelry. Now, you might assume silver is a relic of the past, a leftover from an age of tea sets and pocket watches, especially in a world run by screens and software. But nothing could be further from the truth. Silver is more relevant today than it has ever been. It's the best electrical conductor of any metal on Earth, which, is why it lives quietly inside your smartphone, your laptop, and the electrical contacts that switch on the lights in your home. It's a crucial ingredient in solar panels, helping turn sunlight into clean electricity. And silver has a remarkable secret talent. It's naturally antimicrobial. It kills bacteria on contact, which is why you'll find it woven into wound dressings, coated onto hospital equipment, and even used in water purification systems around the world. On top of all that, it still holds the ancient role it's played for millennia, as a store of wealth treasured by investors in the form of coins and bullion. So the next time you slip on a silver ring, or hand over a silver coin, or unlock the phone in your pocket, pause for just a second, because there is so much more to that shimmer than meets the eye. Behind it lies an entire story, a story of digging deep into darkness, of crushing stone into dust, of taming fire and harnessing electricity. A story of science, of tradition passed down across thousands of years, and of pure human ingenuity. Silver doesn't simply appear. It is made, coaxed out of stubborn rock through effort, patience, and cleverness, using techniques that are still being refined and improved to this very day. And that's a quiet, powerful reminder. Even the most ordinary objects in our lives often carry the most extraordinary journeys behind them. Silver may just be one of the finest examples we have of something beautiful, born from beneath our very feet. Thank you so much for watching. If you have an idea for a topic you'd like us to explore next, drop it in the comments below, and we'll be sure to give you full credit for the suggestion.